Hey all, good morning, wherever you're tuning in from. Welcome to this shortish talk today. I'm going to try and keep it under 20 minutes. Detention pond design with Civil 3D and Storm and Sanitary Analysis. So what we're going to do in this little short video is we're going to create a pond in Civil, kick it out to SSA, and then size it accordingly afterwards. All right, and let's go ahead and let's bounce into Civil. Let's create our pond, and then we're going to jump into SSA afterwards. So right here, here's my Civil file. We just have a pond. This is the pond extent. And so what we're going to do is we're going to just create a quick and dirty pond to kick out to SSA. So running through pond creation. So first thing we're going to do is we're going to create a feature line from objects. There's a polyline right here. We're going to create a feature line from it. So I'll go ahead and select my polyline. And we're just going to create a new site. I'm going to throw it on a pond site. Give it a name. Call it pond extents. And we're going to leave everything else as is, but we're going to assign the elevations to our pond. Assign elevations, okay. Elevation, 10 feet. So it's just an arbitrary number, right? Our elevation at the top of that feature line is going to be 10 feet. Say okay. And now we have a feature line created. So now let's go ahead and let's grade the interior of our pond. So home tab, grading creation tools. And what we're going to do is we're going to verify the site it's on, create a grading group for it, and then proceed with our grading. Set the grading group, pond right here. We'll say okay. Now we need to create a grading group because we don't have one that's a part of that site. Pond. We're going to enable automatic surface creation. So the surface is going to be created as we're grading. So enable that. Okay. Here's our surface we're going to create. Pond. Okay. Now let's go ahead and let's create our grading. So a couple different parameters we can work with: grade to distance, elevation, relative elevation, surface. I'm going to grade to relative elevation. So remember, we're at 10 feet. Relative to 10 feet is what we're going to grade our method. So grade to relative elevation. I'm going to grab this create grading right here. And I'm going to select this feature line. And press enter. We selected it. Select the grading side, inside or outside. We're grading to the inside. So select anywhere inside this polyline. Apply to the entire length. Yes, all the way around. And we'll make our relative elevation -5 feet. So 10 feet to 5 feet. And right here. And now we're going to define how we're getting there. So we're just going to get there with a slope 2 to 1. So slope and 2 to 1. All right, now we're going to do what last step here is create an infill. So we're going to fill in the center of our pond. And you'll know you created the infill when you see the diamond appear. So you notice that highlights here. We go ahead and click. There's our diamond. I'm going to hit escape. I'm going to close this out. And I'm just going to grab my pond and crack it open in Object Viewer. I'm going to take a quick look at it. What did we just create? So here's my pond, the extent of it. Here's the 2 to 1 slope. And then here's my infill, most of the area of that pond. All right, we have our pond created. Now let's kick this out to SSA. So Analyze tab right here. In this design drop down, Stage Storage. And so one thing that's important to note is the contour interval that you have set in this style is how that pond is going to be defined. So what we're going to do here is we're just going to leave our volume calculation to both, and we're going to define our basin from an entity. And we're going to select this define basin. We'll call this pond. And notice here, define basin from surface contours. So we have a 1 and 5. So we have 5 contour intervals in this, 10 feet to 5 feet. I think if you had a wider contour interval or a shorter one, you'd have more data. So let's go ahead and let's just define from surface contours. We're going to define, and I'm going to select my surface right here. And notice, here's my, based on the surface style, here's my stage storage I've created. So let's go ahead and save this table, and then we're going to save it, bring it into Civil. So we'll call this pond design. Hey, we'll call pond design 1. Call pond design 1. Sure, save you. All right, kick your data out. Now let's go ahead and let's set this up in SSA. So launching Storm and Sanitary. What we're going to do is we're going to bring in this CAD file as a background image, so we just have a visual reference of things. So first thing here, View tab, Layer Options. We're going to go ahead and grab that design CAD file right here. Okay, go ahead and grab you. Right behind myself. I'm going to go over there. All right. Let this cook for a second here. All right. Now we have our background image in. And this is just, think of this as like an XREF, but even a simpler one where you can't even extract the data out. But we're okay, we're good with that. We'll say okay. Now we have our background image in here. All right, so let's go and let's start setting up some EG conditions. So what I'm gonna do is I'm just gonna create a subbasin over here. Just in space, there's no method to the madness on exactly where it is. And now let's just go and let's just crack this subbasin open. So we'll just call this EG, and we're just gonna give it some general characteristics to it. So we'll say it's 10 acres. Let's say our time of concentration is 15 minutes. Our weighted curve number, that'll increase based on the amount of development on the site. We'll just leave that as is at 72. And we're gonna go ahead and close this now. Now the next step we're gonna do is we're going to assign a rain gauge. So what's our rainfall onto our subbasin? So right here, add a rain gauge, go ahead and plop you in. Now let's go ahead and let's define the characteristics of this rain gauge. All right, so rain gauge 1, type time series, and now we need to create a time series for it. So we're gonna pull from some existing data to define our rainfall. So grab this ellipsoid right here, and I'm gonna say add a rain gauge. And we could do this with user defined if you want to load a file in, or we're just gonna use what's called Rainfall Designer, some pre-configured data for us. So rainfall type intensity, state Oregon, Clackamas, 100-year storm. So we're gonna see a good amount of rainfall, 4.5 inches of rainfall depth. And we're gonna run an SCS type 2 24-hour storm. So it's gonna be 24 hours in duration we need to run this analysis for. So we'll say okay, we'll say close. We have our rain gauge created here. Now we're gonna go ahead and define that to our subbasin. So we need to tell as to say, hey, this rainfall is gonna be on this subbasin. So here's my rain gauge right here. Go and select you, defined on the subbasin. Now notice here, the next thing we need to do is define our outlet node. So we're just gonna put in a generic outfall just to get the runoff and see what our peak runoff is on our existing site. So right here, add an outfall. It's gonna throw you down on the bottom. And we're gonna right click, I'm gonna say connect to outfall. And notice when I crack open the subbasin this time, we're now going to this outfall right here. All right, now before we run it, we just need to run through our project options and our analysis options first. So input tab right here, input project options. Now think of this as like the master on how everything is being, what calculations are we using to get to our numbers. So you can see our units, hydrology method SCS TR20. Remember I punched in my time of concentration, that 15 minutes. That's because it's user defined. And a couple other things are routing methods. So the kinematic versus hydrodynamic. Bottom line is hydrodynamics a bit more powerful. If you have a pressure condition, hydrodynamics the one to go with. For this scenario, kinematic's gonna be fine. And one thing we're gonna do here is we're just gonna enable our storage node exfiltration method. It's gonna make it constant flow. And we're gonna take a look at that in a second when we start sizing our detention pond. All right, we're gonna say okay here. Now, that was step 1, our project options. Now we're gonna verify our analysis options. So right here, analysis options. So think about this as we've already defined our hydrology methods and all that jazz. Now, how is that data being read within those methods? That's pretty much what our analysis option's about. So we can see here, we have our reporting and routing. So this is what frequency is the data being read at. And what I'm going to do here is I need to define how long are we running this model for. Notice our analysis duration is 0 seconds. We need to make this storm have some length, or this how we're reading our data have some length independent of the storm. So I'm going to end my analysis on the 24th. So 3 days for a 24-hour storm. So what we're going to see is 24 hours of rainfall and then 48 hours of nothing. And the reason I'm doing this is because we're going to let the exfiltration trickle out of the pond, and we're going to see how long it takes to drain it. So 3 days right here, we'll say okay. Now let's go ahead and run our model. Okay, so one thing that I always see happen here is if you want to say okay here, but every time you say okay, it's going to generate a solution file. And if you're running this over and over and over again, you're going to get a lot of solution files. So if you're in that iterative process, just hit the X mark here. Okay. Now let's go ahead, let's just check our subbasin. Let's see what we're working with. All right, so here's our subbasin, and our peak runoff is 22 CFS coming off that subbasin. So 22 CFS is our peak runoff coming off our existing conditions. So now that we have a lay of the land with our existing conditions, let's create our proposed site. So proposed site, we're gonna do the same thing. Create a new subbasin right here. Go ahead and do it. Boom, boom. We'll make it the same size. We'll make some numbers slightly differently so we have more runoff. So area, 10 acres. Time of concentration. I'm gonna make it 5 minutes this time. I'm gonna change my weighted curve number. So we have 72 previously. And we can get an idea here, but I'm gonna make it 98. Paved parking lots, roofs, driveways. So 98. And you can let that curve number be calculated too, so you don't have to be punching in numbers like I am. All right, so we'll go ahead and close this here. Actually, excuse me. Now we need to assign our rain gauge. So same rain gauge is going to be defined for this subbasin. And now we need to define an outlet node for it. So what we're going to do is our outlet node is going to be the storage node. Let's go ahead and close this here. Say okay, close. And we're going to create a storage node. So right here, this is our detention pond. Storage node, I'm going to plop it right in the center of the pond. And now that I have my storage node created, we get to define our volumes for it. So storage node 1, we'll leave that as the default. And what we're going to do is we're going to change our storage shape. So 2 different types. There's functional. Think of this as just a rectangular constant area, a bathtub, a square bathtub. But what we're going to do is we're going to use storage curve and we're going to define it from that stage storage. So right here, storage curves. So very similar to the Rainfall Designer. We're going to add in our storage curve 1, and then we're going to load in our data. Go right here. I'm going to go ahead and grab, let's see. All right. And one thing, just keep in mind, it's this file format, but it'll default to the DAT. And let's go ahead and grab Pond Design 1 right here. All right. Notice here's our depths right here, 5 feet of depth. Here's our total volume, about 106,000 cubic feet. All right, so let's go ahead and just close this now that we have our loaded in our pond data from Civil 3D. And what we're going to do now is we're just going to change a couple parameters for our pond. So first thing, so this is the physical properties of the pond based on the storage node we have inputted. So I'm going to just make this my invert elevation 5 feet, my maximum elevation 10 feet. So we have 5 foot depth of pond. A couple other things we can change here too. So say you had a water surface elevation, ponded area, evaporation loss, all that could be defined. What I'm going to do is I'm going to define my exfiltration. So remember we set that to constant flow in the project options. I'm going to set this to 1 CFS. So it might be a little high, but what we want to do is we just want to watch it come out of the pond. How long does it take to drain at a rate of 1 CFS at all elevations? All right, so go ahead and close this here. And now I'm going to go ahead and connect my subbasin to my storage node. Right click, connect, say okay. All right, now we need to do one thing here at the very end. We need to create an outfall and I'm going to create a weir right at the crest of the pond, so nothing will go through it, but SSA needs to see that in order to run the analysis. So outfall right here, I'm just going to go ahead and plop it, we'll go ahead and plop it like this. All right, now let's go ahead and let's just create a weir right here. Add a weir, and I'm going to click on my storage node. I'm going to click here just to get a little bit of angle and then collect my outfall. So just think if you have a couple of weirs, orifices, and then they're all on top of each other, it can get a little confusing. All right, so here's my weir. I'm going to set my crest elevation of my weir at 10 feet, the very top of the pond. I don't really care about the sizing of this right now because there's not going to be any flow. It's just really to get SSA to run the model so that we can see how that pond is draining. All right, so go ahead and just close this here. And here's my outfall connected. And let's go and let's just double check my subbasin here. Storage node, yep, okay. All right, let's go ahead and run this now. We're running our model now. And so we're running this simultaneously both sides. So just keep in mind when we run it, there's our peak runoff on our EG. Now let's go ahead and let's see what's going on our proposed conditions. Okay, so peak runoff, 58 CFS, so about 3 times more flow coming off in this scenario. And let's go ahead, let's just see what our subbasin's doing. So we can see, here's our subbasin right here. Remember we defined our invert of 5 feet, maximum elevation of 10 feet. Our maximum water depth is 4.48 feet, so call it 4.5. So 4.5 out of the 5 feet. So we're getting pretty close to filling that pond or flooding it. And notice max water depth 4.48, max water elevation 9.48. So 4.48 plus 5, 9.48 feet. And our peak inflow 58.91 CFS. So very close to the sub-basin in terms of probably might be dead on or might be like a tenth or something off. All right, and our constant flow of 1 CFS leaving that pond. All right, let's just go ahead and let's just check out our weir. I'm not expecting any flow in that weir because it's set at 10 feet. But let's go ahead and let's just see. All right, cool. Crest elevation 10 feet. Peak flow is 0. We have no flow through that weir. And if we go ahead and grab this outfall, we'll see no flow through that as well. So no water depth, no peak inflow. So all that water is leaving the subbasin and going directly into the pond and not leaving that pond. All right, now that we have that exfiltration method set at 1 CFS, let's go ahead and let's just see our time series plots. So selecting that storage node, display time series plot here. This is a great way to see analysis of your data for any element in the model. So what we can see here is I'm going to go, remember, let's start at the top of the chain. So our subbasins. Here's our rain. We'll do our runoff. So here's our EG right here. So you can see, remember it was about 22 CFS. So if I grab the top here, at 12 hours, we're at 21.75. And same thing for subbasin 2. I'm going to grab this, and we see this is our peak flow, 58 CFS at about the same time. So that's what's coming off our subbasins in terms of flow. Now let's go ahead and let's just check out our nodes right here. So here's my outfall 1 right here. So what we're going to see here is we're going to see about 22 CFS, 21 and change. And outfall 2 isn't going to have any flow in it because it doesn't see any flow. But now let's check out our storage node right here. So if I go ahead and uncheck my subbasin just to make the graphs a little bigger, here's the flow coming into my subbasin. So 58 CFS. Makes sense coming from the subbasin. All right, now let's check out our volume right here. This is the volume, the change in volume of our pond. I'm gonna go ahead and unselect this. I'm gonna grab our storage node. Remember, we ran this for 3 days, 72 hours. So that's why our graph is showing 72 all the way out here. But notice, here's our volume coming in. And if we go to our peak here, makes sense. We're at about, we're about 93,000. Remember, our total volume of our pond was around 100,000 or a little over. So that makes sense with that 4.5 feet of elevation at our max water depth. And then we can see slowly where the volume is leaving the pond at that rate of 1 CFS. And we can also check out our exfiltration here too. We'll close that volume here, grab our exfiltration storage node right here. And we can see here our exfiltration starts at about 8 hours and change. We're at 1 CFS the entire time, and that just drastically drops off when there's no more flow left in there. All right, so let's go ahead and let's just let's size our pond in terms of how we want to work with it. So one thing we can do is we can just let everything drain out, like we have here. Another situation is we could have no exfiltration in our pond. So let's go ahead and change that. So we'll change this to 0 or no exfiltration. So there's going to be no flow leaving our pond. And what we're going to do now is we're going to throw in an orifice and size that and compare that to our peak flow from our existing conditions. So go ahead and close this here. Remember, we have a weir here at 10 feet. What we're going to do now is we're going to throw in an orifice. So right here, orifice. And I'm just going to draw it something like this right here and connect to the outfall. All right, here's our orifice. We'll just leave it all generic as is. So just notice our diameter is 12 inches, sizing like that. I'm going to make it, our pond invert elevation's 5 feet. So let's create our orifice at 6 feet. So our orifice is created at 6 feet. Let's go ahead and let's run our model here. And so one thing we here, let's see what flow we have through our orifice. So we have a peak flow of 6.46 CFS leaving our orifice. So that's under our proposed conditions of 22 CFS. Another thing we can do is we can check our storage nodes right here. So display the time series plot right here. And that's our total inflow, which remains the same. But let's go ahead, let's just check our volume of our pond here. So here's the volume, the storage node. And notice we're tapering off. We still have flow leaving the pond after 72 hours. We have about 18,000 CFS in there. So at that rate of 8 CFS, that's what the volume's leaving the pond. And notice if we grab our exfiltration here, We can grab our exfiltration. We notice we have none since we changed that to 0. So let's play with a different number. Let's say we have half a CFS of exfiltration. Let's see how long it takes to drain. Does it drain within 72 hours? All right, storage node right here at all elevations. We'll make it half a CFS. Go ahead and close. And we're going to go ahead and run this model again. All right, go ahead and just close this here. We're going to see we have about the same flow, 5.92. I think it might be a little less, but same flow leaving that orifice. But what we're going to see now is we're going to see that, we're going to see less volume in the pond after 72 hours. So go ahead and grab our storage node here and display time series plot. And click U. Now we're going to see our volume here in our storage node. So notice now our pond completely empties at about 36 hours and change. So we can see here's that that 1 CFS or that half a CFS of exfiltration paired with the orifice, 12-inch orifice at a 6-foot invert. Now, one thing we can see here is I'm guessing right here, this is where it goes that last foot of pond. So that's 6 feet to 5 feet. So we saw or excuse me, this is when the orifice and the exfiltration are together. And then now we hit an elevation of 6 feet in the pond. And now we just have that 1 foot of exfiltration, or that half a CFS of exfiltration for the remaining few hours of the analysis. All right, so want to thank you. Thank you for giving me, let me show you a few things about SSA and Civil 3D. Hopefully you find this helpful with designing ponds and creating them in Civil, kicking them out to SSA, and just getting an overview of how SSA could work with your design process. So thank you for your time and have a great rest of your week.